Welcome. Now today's class, but question I will read first. Question 98. Actually, some important note I will give you. This is for question 98, what you are solving now, comma 99 and 100. All the three, some concepts are there. Remember, it is for steel structures. People who are not interested in steel structures or not in civil engineering, they need not bother too much. But when I cover moment of inertia, I told I am covering everything. So see, first I read question. The cross section of a column consists of two RSJs. I told you RSJ means, see, rolled steel joist I section. So this is today's part E of classes, moment of inertia classes dedicated to steel structure. You should start from part A, not from here. If you suppose you only see this class, you will not understand. You will start wondering what is going on here. So start from beginning your study. Okay. See, this is line diagram. See, two I sections are placed here. Question is, find the spacing. See here, this spacing, yes, it is center to center spacing. See, from this center to this center. For moment of inertia about both centroidal axes to be same. I will tell in the class what is the meaning. For others, I will tell you later. See, important. In case of steel structures, when you go for built up column, you get two RSJs, see here, placed side by side. One more here, one more here. And if you see front view, this is a plan, cross section, see, you can see the column like this. Then these two are properly connected, see, either by lacing this way or by battens. See, this way, battens, rough sketch. This way, battens will be there. You have seen this one in railway station, bus stops, etc. Okay. Now, our important is, in these cases, see, the two RSJs here. Today, question 98 is two RSJs. See here, question 98 is two RSJs. Question 99 are for two channels. Two channels. See, this way. Either can be placed back to back like this, or can be faced. This is question number 99. This is question number 100. Or can be placed face to face. See. Here. Of course, see, here connection will be, they are properly connected. That is very important. They are properly connected. That is lacing or battening. In the IS code they told, in such cases, IS code mentioned that I about this YY axis here should not be less than I about XX. These all reasons, what is the reason you study in steel structures? Now, what we are doing now is, at that time, a term called slenderness ratio will come. Slenderness ratio. Say lambda equal to L effective by R. R is radius of gyration. R equal to root of I by A. So R is directly, A is constant, directly proportional to I. As I increases, R also increases. Now, what most economical design is, when slenderness ratio lambda is same with respect to both XX and YY axis. See, everywhere same with respect to both XX and YY axis. If lambda with, see, lambda with respect to XX axis equal to L effective by R about XX, and lambda with respect to YY axis is L effective by RYY. Again, RXX equal to root of IXX divided by A, RYY equal to root of IYY divided by A. So there we want slenderness ratio to be same with respect to both axes. Or for lambda to be same, see now, for lambda about XX equal to lambda about XX equal to lambda about yy, your rxx should be equal to ryy. And for, you can see here, for rxx equal to ryy, ixx should be equal to iyy. This all you will be studying in steel structures, not here. I am just telling what is going on, that's all. So some people, see, those who study engineering mechanics start wondering what is going on. Don't worry. So finally, I will tell you, furthermore I won't tell now, reason for that one, why I equal I about both the axes are advantage and most economical, that reason will come in steel structures. Therefore, after all this one, I will tell you, finally, sorry, I rubbed it. For finally, see, finally, for our engineering mechanics class, question is to find spacing. The spacing can be either centered center or clear. In RSJ, see, this is centered center spacing. This is clear spacing. Both okay. But a channel solve, there is no centered center because it is not symmetrical. In channel, it is clear spacing. So finally, to find spacing for, that is, you have to find S for I about XX equal to I about YY. So what is the procedure? Procedure is find IXX. Find IXX. In IXX term, spacing S will not come. Y means you don't bother. The spacing S will not come. So IXX, we will get the answer. Value will come. How much is IXX? Value will come. Then find IYY. IYY. IYY will come in terms of spacing S. In terms of spacing S. Then equate, see, equate IXX to IYY and find the spacing. Find S. Right here. That's all for our engineering mechanics class. Further things you study in steel structures. Okay. Now, so finally remember all these questions, what you have to do, you write expression for IXX, write expression for IYY, and then equate IXX, IYY. In the expression for IXX, spacing will not come. Y means you see later. But in the expression for IYY, spacing S will come. You can make out there. As the spacing increases, IYY will increase. In the steel structure, I will show you something. See, IXX here. Low spacing, IYY is lesser. To make economical, increase the spacing, I will tell. Finally, a stage will come when your IXX will become equal to IYY. That is called the most economical spacing. That's all here. Now, start first question. Here. Question 98. See, two RSJs other properties are given. See here. Now, this is question. Don't write anything here. When you start solution, see, when you start solution, first what you do? First write the cross section. Cross section, all dimensions in millimeter. See, one I section here. Okay. See, 1 minute here. Okay. One I section here. Rough sketch I will draw. I won't waste time too much actually. About, okay, as neat as possible. Those who want can draw neatly later. One I section here, then somewhere here, another I section, same width. Okay. Whatever width is identical. It should be identical, otherwise there is no meaning for this question. One more I section. Okay. That's why I always write the sketch before recording. Okay, roughly okay, I think. Okay, roughly okay. Okay, no problem, don't worry. Now, here, see, you mark, where is the pen? I don't know where I kept it. Green color for marking number 1 and 2. Here, okay. Now see, here, this I will take 1. This I will take 2. So, this is one component. This all I explained earlier. This is another component, 2. Both are same section. Now, this is G1. See here, centroid for this one. Same level, this is G2. Now, properties for the RSJ, one of them, it is for both 1 and 2 is, see, first you require breadth of flange. You may require, it is given in the question, how much? 150 millimeter. It is given in the question, 150. Then, total area given, 9227. 9227 mm square. I about xx given means, see, I about this axis. See, ix axis, how much? 30390, 0.8, space problem here, into 10 to the power 4 millimeter power 4. Iyy also given, 834 into 10 to the power 4 millimeter power 4. Okay. Now, see, we want to find center to center spacing. So, mark it here. Center to center spacing is, where I kept the red color pen. Okay, here, see. This is the, see, now first of all, see, this is x-axis. X-axis. Exactly here, this will be y-y axis. Y-y. Okay, now, before that, see, this is called depth of section H. I told you, 450 means H equal to 450. Understood? And this is, both are, see, this is H by 2, this is also H by 2. If you require this axis. Okay, now, they told, see, from this centroid G1 to this centroid G2, this distance is S. Yes, this S you have to find. So, we have to find S, that is center to center spacing. Remember, spacing for our condition is for I about xx equal to I about yy. Okay, you have to find S spacing for ixx equal to iyy. Start. First write ixx. See here. I about, see, the other things are not required. I about its own centroidal axis. That is this axis. How much? 30390.8 into 10 to the power 4 Ig plus area is 9227 is the area into from G1 to xx perpendicular. Centroid G1 lies in the xx axis, so into 0 square. That's all. You calculate this answer first. It will come in 10 to the power 6 millimeter power 4. I will write the answer. 1 minute. This I have to calculate. Where is my calculator? It's here. Okay. This is how much? 30390.8 10 to the power 4. That's all. Into 2. 10 to the power 6 I will write. 607.816. It is 607.816 10 to the power 6 millimeter power 4. Okay, now write Iyy. See here. Iyy. Iyy. Come here. One thing forgotten. See, I actually did it. No. This one, see, into 0 square, I forgot it. Okay. Into 0 square, see the most important. Whatever you get, this is for one I section. See, forgot it. Multiplied by 2. Okay, I multiplied by 2. See, because I know it is twice. So I forgot to write, but into 2. Okay, I. Start. I about its own centroidal axis here. This axis is I about this axis. 834 10 to the power 4. 834 into 10 to the power 4 is Ig, plus area is 9227 is the area, into, see, into, from centroid G1 to YY, see, this distance, when this is S, this will be S by 2, this also is S by 2 into S by 2 whole square is Iyy. Whatever you get, then identical to multiply by 2. What will happen now? Now you will get first one numerical value. See here, 834 10 to the power 4 into 2 will give you 10 to the power 6 if you write 16.68 10 to the power 6 plus 9227, see here, 9227 into 1 by 2 square into 1 by 2 square is 9227 divided by 4, then into 2. It will come 4613.5. Total answer 4613.5 times what? Times S square. Times 1 minute, I get 834. I check the camera once again. Okay. Into S square will come. See. Into S, capital S, okay. Into times S square. This much millimeter power 4. Millimeter power 4. This answer. I'll check once again now. Okay, not required. That is correct. 834 10 to the power 4 into 2 is 116.68. Other one is 9227 into 1 by 2 square is into 1 by 4 equal to, then into 2. Yes, 4613.5 times S square will come. Now write here. Therefore, see, therefore, for Ixx, no, not for, already over, I wrote already, see, I already wrote procedure. So, okay, right here. Therefore, for your Ixx equal to Iyy, what is the answer? You get 607.816 10 to the power 6 equal to 16.68 10 to the power 6 plus 4613.5 times S square. Therefore, you will get the value of S. Answer, S will come in millimeter. This is what? Center to center spacing. See, this is, or I write it, this is center to center spacing. It calculates the value and close this question. That's all. There further things are there. 607.816 10 to the power 6 minus 16.68 10 to the power 6 divided by 4613.5. Whatever I got, take square root. Root answer 357.955. 357.955 is the answer. It is 357.955 millimeter is the answer. Now make a note. You make a note after everything is over. Okay, everything is over now. See, now make a note somewhere. Suppose instead of center to center spacing, clear spacing is required. Clear spacing is required. Spacing is required. Then see here. Then also, first find what? First find S center to center. Okay, first find S center to center. Right here, answer. Answer is S equal to 357.955 millimeter. We already got. Then see, why. This is the clear spacing. See here, this is the clear spacing. Then clear spacing equal to whatever center to center you got. How much it is? 357.955. That is center to center spacing. See, from that spacing, yes, subtract half of this one, subtract this one. That is, breadth of flange is 150 mm. Means, see, this full is 150 here. 150. So from this one, subtract 150 by 2, subtract 150 by 2, minus 150 by 2, minus 150 by 2. That is, subtract 300, correct? No, subtract 150 by 2. Your answer will be not 300, 150 only. 350 minus 150 is 207.955 millimeter is the answer. Just make a note. Okay, I will now go to next question number 99. 1 minute. Before that, I will check the camera once. By chance, anything is out of the camera. No, I think okay. Okay, yes, slightly I have to move this side. That 1 millimeter power 4 is not fully visible. Okay, now fully okay. Everything is ready. Okay. Question 99. Same identical question. See, the cross section of a column consists of two channels ISMC 400. This we used earlier. Placed back to back as shown. Actually, once they give placed back to back, as shown is not required. You can write here. Placed back to back. Okay, then find the spacing S. That means, see, they want the clear spacing now. For moment of inertia, about both centroidal axes to be same. Class already explained what is going on. Properties are given in the question here. Write the properties. These all I explained for you. Breadth of flange, depth of section H. The depth of section H equal to whatever is the number. Number is 400 millimeter. Then centroid is here. This way is midway. But this way, this is called CYY. Centroidal distance of YYC given in the question. Sorry, I should give it here. Otherwise, question you cannot solve. CYY equal to 24.2 millimeter given in the question. Okay, start. Now, first mark axis. See here. This is your XX axis. XX. It will come here. Midway. This is your YY. YY. See. Clear spacing is yes. When this is YY, see, when YY comes here, if you want from here to here and here to here, it will be S by 2 and S by 2. S by 2 and S by 2. That is the distance. Okay, start. Now, right here, require to find, if you want you can write, require to find clear spacing S, clear spacing, that is S for IXX equal to IYY. Start. Write I about XX axis. First, any channel, okay, take this channel. See, channel 1, channel 2, take this one, by same as that one, see. I about its own centroidal axis. 15082, 15082.8, 10 to the power 4 Ig plus area, 6293 is the area, into centroid lies in XX, into what? Into 0 square. 0 square. Whatever you get, multiply by 2. So you will get IXX. Value will come, no S will come there. See, 15082.8, calculate is not on, 15082.8 into 1 10 to the power 4, okay, into 2, divide by 10 to the power 6, 301.656. This is 301.656 10 to the power 6 millimeter power 4. Okay. Then now write IYY. IYY equal to, see here, first I about its own centroidal axis, here parallel to YY, this axis. That axis is this axis. How much? 504.8. It is 504.8 10 to the power 4 is IG plus 6293 is the area into, very important now, see, into, see correctly, from centroid G2 to YY, see, this distance square is S by 2, see, it is, or you can start from here, okay, S by 2 plus another from here to here is, see, it is CYY 24.2 plus 24.2 close square, okay, then multiply by 2. When you calculate, this will come, I will write it inclined, I will write here, inclined way. First a number will come here, see, 504.8 10 to the power 4 into 2 is 10 to the power 6 I want, 10.096. It is 10.096 10 to the power 6 is 2 into this number plus 6293, see, don't touch this one now, leave it, into 2 is 12586. 12586 times, how much? S by 2, I will use red color for that one, into S by 2 plus 24.2 whole square is the answer. Now, right, equating IXX to IYY, what you get? 301.656 10 to the power 6 equal to 10.096 10 to the power 6 plus 12586 times, see, S by 2 plus 24.2 whole square. Now, therefore, S will come in millimeter. See, how to operate calculator I will tell you. See, first, what I will do, you simplify this one. 301.656 10 to the power 6. Okay. From this number, I will subtract this number, minus 10.096 10 to the power 6. Oh, see, gone. 301.656 10 to the power 6 minus 10.096 10 to the power 6. I will get this number. I will divide by 12586. One value will come now. I will store in memory because I require for next round. Okay, answer. Okay, then shift store A. Whatever I got, see, I will take root first. Root answer. That will give you this value. I will subtract 24.2. Then I will multiply by 2. 257.566 millimeter. I'll just check the answer once again. 301.656 minus 10.096 into 10 to the power 6 divided by 12586. Then root answer minus 24.2 into 2. 256, correct, 256 coming up. Something wrong. 301.656 minus 10.096 10 to the power 6 common divided by 12586 equal to root answer equal to so much minus 24.2 equal to into 2. 256 is coming. Okay, suppose wrong, why worry? You correct it. 256.004 millimeter. Okay, suppose this is some mistake is there, correct it. What is there? Okay, this is question number 99. Now, lastly, I'll do question number 100, last question of this series. Over now. The cross section of a column consists of two channels. ISMC, I will use same thing to save the time, same, but one thing, placed, I write here, face to face, as shown. How? One channel here, one channel here. Again, this is spacing S. Find the spacing S. Everything is same. Your sketch will change. The property also will be same. But your sketch will change. But some you can make out now what is the change now. See, one channel here. With rough sketch I will write. I won't give too much importance to shape all, but should look like channel. Okay. Okay, done. Okay, then somewhere here. How much? This much distance here also. Okay. Don't worry about too much about these things all. There's a limit for everything. Okay, these are two channels. Looks okay. Okay, I will take, see, 1 and 2. Let me neatly write here. As usual, I will take this as 1, this is 2. See, this is 1, this is 2. Then centroid, see here, this is centroid G1. This is centroid G2. Okay, now x-axis, how? X-axis will come here. This question is same as last question. X-axis here. Okay. Y will come here. Y will come here. I think what happened is, okay, now done. Okay, Y here. Now see, this clear spacing is yes. Clear spacing is yes. If that is yes, this will be S by 2 and S by 2. Okay, start. Now, centroid is here, G. This is already known for you. First find IXX, same statement. Now consider this channel. Why? This channel is as per that channel. See, I about its own centroidal axis. 1582.8 10 to the power 4 plus area into 0 square into 2. Oh, same as last time. So by changing the nature of the fixed spacing, IXX remained same, but IYY, see here. First, I about its own centroidal axis. Same. How much? About this axis. 504.8 10 to the power 4 plus 6293 is the area into, now you should be careful, see. See now. Now, 6293 area into, see, this distance square. So that is S by 2, see here, S by 2 plus, now you require this width of flange. This width of flange is how much? 100 millimeter. See, 100. S by 2 plus 100. See, we want from centroid G1 to YY, see, this distance square. That is S by 2 plus 100 minus this distance is 24.2. 24.2, then whole square. That also multiply by 2. Okay, now equate IXX to IYY. You do it, get the spacing, yes. Same answer will not come, different answer will come. That is because spacing arrangement is changed. Okay, I will give the answer for you. How much it is? 301.656 10 to the power 6 minus, other one is 504.8 10 to the power 4 into 2, okay, into 2 over, divide by 6293, divide by 2, okay, root answer will give you minus 100 plus 24.2 plus 24.2 then into 2. 152.804. 152.804 is the answer. If the answer is wrong, you find the correct answer. See, because we are not using it. 152 point, forgot. That's how my memory works when numbers are there. 152.804. 152.804 is the answer. 804. See, in engineering mechanics class, what you do? You write expression for Ixx, expression for Iyy, and equate them, because the question is finding that unknown spacing for equal moment of inertia. That's all engineering mechanics. In steel structures, this two RSJs or two channel placed with lacing and battening, etc., I take more than 20 hours. Why? Lot of concept is there. Design of lacing will come there, so many things will come. But in steel structures, only moment of inertia. Okay, now 100 over. Next class, we'll continue. Another 2 more classes required for that moment of inertia part dedicated to steel structure. Okay, then I will back to old one. Okay, we'll meet next time. Thank you.